Before dinosaurs ever thundered across the Earth, the planet belonged to a completely different cast of monsters. Saber-toothed reptiles, sail-backed killers, boomerang-headed amphibians, and burrowing survivors built for a world far harsher than anything Jurassic Park ever imagined. These were the beasts that ruled long before the first dinosaur egg even formed. Creatures so strange, powerful, and often terrifying that they feel like evolution's early experiments in building predators, giants, and survivors. Today, we're travelling back hundreds of millions of years to meet the forgotten rulers of deep time, the beasts that walked before any dinosaur existed. Dimetrodon, the sail-backed apex predator. If you think back to a time before dinosaurs, picture a hot swamp. Along the dark water, there are waist-high ferns, and something moves between the trees. It has 4 short legs that move its long body forward. Its heavy head moves from side to side, and a tall sail hangs from its back like a strange flag. This is Dimetrodon, the best hunter in its world. Many people still mistake Dimetrodon for a dinosaur because it often appears beside T-Rex in books and toys. In truth, it lived around 40 to 50 million years before the first dinosaurs. Dimetrodon was a synapside, part of the same broader line that would much later produce mammals. That makes it a distant cousin of ours, not a cousin of the dinosaurs, even though its body looks reptile-like at first glance. Most species of Dimetrodon were between 2 and 3 meters long. All of them had big skulls with strong jaws and sharp teeth of different sizes. The front teeth were pointed for grabbing. Farther back, the teeth had cutting edges that worked like rows of knives. When Dimetrodon bit down, it did not just hold on, it sliced deep into flesh and finished hunts quickly. The most famous part of Dimetrodon is the sail on its back. Tall bony spines rose up from each backbone and skin stretched between them to form a high, flat surface. At first, scientists thought the sail's main job was to control body heat. In the cool morning, the animal could turn the sail to the sun and warm up fast. Later in the day, it could turn sideways to the wind and shed extra warmth. This idea still makes sense, but newer studies suggest that is not the whole story. When researchers compared different Dimetrodon species, they noticed something odd. Some smaller animals had very large sails, while some bigger animals had only modest sails. That pattern is hard to explain if the sail was only a heater. It fits better if the sail also acted as a display, helping animals spot their own kind, impress mates, or scare rivals without a fight. In life, the sail may have carried simple stripes or spots that stood out against the swamp. Bone slices from the sail spines add more detail. Under the microscope, the tissue shows many small channels for blood vessels, meaning the sail was living, active tissue. Some spines even show healed breaks, proof that the sail could be damaged and then repaired. Dimetrodon could push through plants, scrape against rocks, even clash with other animals, and still keep its sail. Most Dimetrodon fossils come from the red bedrocks of Texas and Oklahoma, which once were warm lowlands full of rivers and wetlands. There, it lived alongside big plant eaters like Edaphosaurus and large amphibians such as Eryops. Finds from other parts of North America and from Germany show that Dimetrodon spread widely across the supercontinent and often sat at the top of the food chain. What kind of hunt did it do? Not fully spread out like a lizard's, its legs sat partway under its body. This gave it more power to get off the ground. It probably wasn't made for long runs, but for short, strong bursts. Think of a Dimetrodon relaxing in the shade next to a watering hole. The tips of its sail can just be seen above the tall plants. A hunter could move quickly and low to catch a thirsty animal that came close. It could then slam its teeth shut and drag the animal down before it could get away. Gorgonops, the saber-toothed reptile of the Permian. A cracked red plain is covered in dust. Low trees cast narrow strips of shade, and groups of big plant eaters walk toward a waterhole that is getting smaller. Something thin and low moves with a smooth trot between their legs. Every other animal seems much less important when a narrow head rises and two long teeth catch the light. This is Gorgonops, one of the first ground animals that was designed to be scary. Gorgonops belonged to a group called therapsids, distant relatives of mammals. It was not a dinosaur and not a lizard, but part of the line that would one day lead to creatures more like us. Its skull was long and shallow, with large openings for jaw muscles and sensors packed toward the front. The eyes sat high and slightly forward, giving enough depth vision to judge distance when it lunged. Its main weapons were the saber-like canine teeth. These upper fangs were much longer than the others and curved gently backward. Even with the mouth closed, their tips still reached below the lower jaw. To fit them, Gorgonops needed a jaw that opened very wide, and the bones show that the lower jaw could swing down to a huge angle, letting the sabers clear the jaw and stab into soft flesh. Those teeth were made to cut, not crush. A bite from Gorgonops was probably quick and deep, aimed at the throat, belly, or inside of a leg, where blood flows close to the surface. After a strike, it could pull back and let the wound weaken the animal instead of wrestling it down right away. If the prey kept moving, Gorgonops could follow at a steady trot and bite again when it slowed. Long before saber-toothed cats appeared, this Permian hunter was already using a strike and retreat style of killing. That's how the rest of its body worked. Gorgonops did not drag its bottom in the dirt like many other snakes of the time. It had part of its legs tucked under its body, which made it stand taller and give each step more force. Soles and hips were made for short bursts of speed, not long runs. Just a short, sharp rush from cover was enough on open ground next to rivers and floodplains. Gorgonops shared its world with heavy plant eaters such as Diictodons and Periosaurs. These animals had thick bodies and sometimes bony armor, but they were not built to outrun a determined hunter. Gorgonops sat near the top of that food web, picking off the young, the weak, and sometimes even healthy adults when it landed a perfect bite. Fossil sites where Gorgonopsian teeth lie, mixed with the bones of large herbivores, hint at feeding scenes that played out many times on the Permian plains. Inside its bones, Gorgonops shows signs of fast growth. When scientists slice its limb bones, they see tissue that looks more like that of later mammal ancestors than that of slow-growing reptiles. There are fewer clear growth rings and more woven, active-looking bones. This suggests that young Gorgonops individuals grew quickly to reach a safer size, then kept a fairly high level of activity through life, burning more energy than a cold, sluggish reptile. Gorgonops wasn't always nice to its own kind. A close cousin has a broken canine from someone else that is stuck and healed into the brain. This is proof of a fight where one fang broke off and got stuck in bone, but the victim still lived. Those kinds of fights could have been overmates, territory, or kills. We still don't know if Gorgonops had scales, hair, or a mix of the two on the outside, because no skin has been found. We can picture a thin, low body with a long tail for balance, a strong neck, and a head full of muscles that end in two huge knives. This saber-toothed therapsid was trying the same tools that later mammal hunters would use: eyes that looked forward, fast growth, strong jaws, and teeth made to take down big prey. This happened long before any dinosaur eggs were laid. Edaphosaurus, the plant-eating sailback giant. From far away, Edaphosaurus looks like Dimetrodon's quiet brother. It has the same low body, tall sail, and early Permian mudflats. The differences stand out more as you get closer though. The body is shaped like a loaded barrel on 4 posts, and the head is short and flat. The lips have round, stubby teeth. This killer did not follow the person. This was one of the first big animals that ate plants to walk on land. Edaphosaurus lived about 280 million years ago, long before dinosaurs, crocodiles or birds. Like Dimetrodon, it was a synapsid, part of the branch that would one day produce mammals. That means it sits on our side of the family tree, even if it looks reptile-like in most drawings. Its job in the ecosystem was simple but demanding. Eat low-value food all day, every day, and turn it into muscle, fat, and the next generation. The ribs flare wide and deep, leaving plenty of room for a large gut where tough plant tissue could sit and break down. When your food is mostly stems, roots, and coarse leaves, you do not need long legs for sprinting. You need a big internal factory to squeeze out every bit of energy. Today, cows and horses solve that with complex stomachs. Edaphosaurus reached for a similar solution by building a broad, heavy torso. Its limbs were thick and sturdy, angled partly out to the sides but not completely flat like a lizard's. They supported that heavy body without much trouble, but they were never built for speed. Edaphosaurus likely moved with a slow, rocking walk, head low, sweeping back and forth as it grazed along riverbanks and wet ground. When danger came, it probably relied less on escape and more on bulk, a tough hide, and the safety of being one big target among many others in a loose herd. The teeth and jaws confirm the plant-eating lifestyle. Instead of knife-like blades, Edaphosaurus had small peg teeth along the jaws and extra rough surfaces at the back of the mouth that worked like grinding pads. They crushed soft shoots and shredded tougher stems so the gut could finish the job. The skull itself is short and narrow, more suited to nipping off mouthfuls than biting and shaking. Picture it patiently clipping low ferns, simple seed plants, and any tender growth it could reach. Then there is the sail, the feature that makes it unforgettable. Tall spines rose from the backbone, but unlike Dimetrodon's smooth ones, these spines carried small side branches, like pegs on a pole. In life, skin and blood vessels wrapped over them to form a sail that was probably knobbly and uneven rather than smooth and fin-like. It was a living sheet of tissue, crossed by veins and nerves, not just a row of dead spikes. Why would a slow grazer carry such a strange structure? One answer is temperature control. A broad surface filled with blood can absorb warmth in chilly mornings and dump heat when the day turns brutal. But the extra side branches hint at more. They may have stiffened the sail or supported thicker tissue, maybe even small fat stores. Many researchers also see the sail as a billboard. A tall, patterned panel on your back helps your own kind find you across open flats and lets rivals or mates judge your size and condition without risking a fight. Platyoposaurus, the river ambusher of the Permian floodplains. The Permian wasn't just home to hunters on sails and people who ate a lot of plants. There was a different kind of animal that lived in the warm rivers and winding channels of what is now Russia. It was about 2.5 meters long and had a head that looked like a crocodile's. Its body was built to sit low in the water and wait. If Dimetrodon owned the banks, then Platyoposaurus owned the dark water next to them. Unlike fish, Platyoposaurus had sturdy legs and could haul itself onto sandbars or mudflats, but most of its power came from the tail. Long and flattened from side to side, it worked like a paddle, pushing the animal forward in fast bursts. When it rested, Platyoposaurus likely sat with just its eyes and nostrils above the surface, almost motionless, watching everything that moved near the shore. To a thirsty reptile or a careless fish, the water would have looked calm and harmless. Its skull explains how it hunted. Platyoposaurus had a wide, flat head, with the eyes placed high and slightly toward the back, that let it look upward and forward while most of the head stayed hidden. The jaws were lined with rows of small, sharp teeth, perfect for gripping slippery prey. Inside, the bone shows a complex pattern of folds in the tooth roots, a classic feature of ancient amphibians that helped strengthen the teeth against sudden shocks. When the jaws snapped shut, they clamped like a trap. Most fossils of Platyoposaurus come from old river deposits near the Ural Mountains. These rocks show not just one animal, but whole communities: fish, smaller amphibians, and early reptile relatives. In that setting, Platyoposaurus sat near the top of the freshwater food chain. It could swallow smaller animals whole and tear chunks from larger ones. Young individuals may have fed mostly on insects and tiny fish, while adults could handle anything unlucky enough to pass in front of their snouts. Scientists learn about its life from the bones themselves. When they cut thin slices through the limb bones, they see growth rings, a bit like those in a tree. These rings suggest Platyoposaurus grew in pulses, speeding up in good seasons and slowing down when food or water was scarce. Some bones show signs of healed damage, hinting that older animals survived bites, collisions, or even attacks from their own kind. In crowded river systems, jaws and teeth were never far away. The skull also gives clues about its senses. Grooves along the surface likely held nerves and blood vessels for pressure-sensing organs similar to those in modern aquatic animals. With these, Platyoposaurus could feel tiny vibrations in the water, detecting the movement of prey even in murky light or at night. Combined with decent vision above the surface, it was well equipped to strike from below, where its own outline was hardest to see. On land, Platyoposaurus would have looked less graceful. Its legs splayed out, and its belly sat close to the ground, making walking slow and awkward. Still, short trips onto flooded banks were probably important. It could bask to warm up, move between pools as rivers shrank in dry periods, or retreat into burrow-like hollows during droughts. In this way, it bridged worlds, part river monster, part clumsy land crawler, living at the edge of two environments that were always changing. In Permian communities, Platyoposaurus also shows how power was shared. The first synapsids and snakes lived on land and fought and killed. Big frogs like this one set the rules in the water. Any small tetrapod that tried to cross a channel ran the risk of being swept away in a quick splash. When fish and other animals in the water came to the surface, they were met with a roof of teeth. The technique of wait in the shallows and strike was used by Platyoposaurus and its relatives long before crocodiles developed. It still works very well today. Anteosaurus, the heavyweight skull crusher. Back in the Middle Permian in South Africa, a long time before dinosaurs, the most dangerous animal on land wasn't a lizard. It was a huge synapside named Anteosaurus. Picture a 5-meter-long animal with a thick, heavy head, big teeth that look like sabers, and a body built like a crocodile's with long legs. Anteosaurus belonged to a group called Dinocephalians, terrible heads, and it earned that name. Its skull could reach close to a meter in length and was packed with dense bone. The roof of the skull was swollen into solid bosses, and there was a bony lump on the lower jaw as well. These reinforced areas turned its head into armor and weapons. For a long time, scientists thought such a heavy-headed animal must have been slow and clumsy, more like a land crocodile that waited in ambush than an active hunter. But new research has shaken that idea. In a recent study, paleontologists put an Anteosaurus skull in a high-powered X-ray scanner and rebuilt the brain cavity and inner ear in 3 dimensions. The inner ear canals, which help animals keep balance and control fast head movements, were large. Parts of the brain that link eye and head motion were also well developed. Together, these features point to an animal that could move its head quickly and track targets while running, not a sluggish brute. Its teeth support the idea that it is a dangerous animal. Anteosaurus had big incisors in the front of its jaws that locked together when it bit down, making a strong grip on its food. Behind them were huge teeth that were shorter than some saber-toothed Gorgonopsians, but still long and strong enough to cut through skin. In the back, A row of posts was made up of smaller but stronger teeth. Extra teeth on raised pads on the roof of the mouth helped hold meat while the jaws worked. Most fossils of Anteosaurus come from the Karoo Basin of South Africa, in rock layers laid down by broad rivers that flowed across a vast plain. The land was dotted with swamps, shallow lakes, and forests of seed ferns. Herds of giant plant-eaters like Moschops, Tapinocephalus, and Periosaurs wandered through this landscape, feeding on thick vegetation. Those animals were big, some as heavy as small cars, but they were also slow. Anteosaurus seems to have been built to bring them down, standing at the very top of this food web. A study of bone microstructure from several skeleton pieces shows a mix of dense outer bone and lighter inner bone filled with struts. This pattern suggests a powerful, land-living animal that still spent time near water, maybe cooling off in shallow pools, like a modern hippo, but hunting mainly on land. The bones also show steady growth rather than long pauses, which fits a predator that needs to stay active and keep up with prey. The limbs of Anteosaurus are known from only a few finds, but what we do have shows strong, weight-bearing bones and hands with a finger pattern similar to that of later mammals. The inner fingers were shorter, while the outer ones were long and robust, good for pushing off the ground. Even without a full skeleton, we can tell it stood high enough to look over many of the plant-eaters it hunted, and could drive forward in powerful strides when it attacked. Anteosaurus did not live forever. It appears in rocks from one set of Middle Permian layers and disappears in the next, right around the time of an extinction event that wiped out Dinocephalians as a group. Huge volcanic eruptions and drying habitats broke down the rich river ecosystems that had fed it. When the herds of large plant-eaters crashed, their skull-crushing hunter went with them. Scutosaurus, the armoured herbivore that refused to die quietly. Some plant-eaters in the late Permian did not depend on being fast or hidden. Their defence was on the outside. One of these living tanks was Scutosaurus, a wide, low animal with bony plates and bumps all over its body. It moved slowly across dusty floodplains that would one day be gone in the biggest mass extinction the Earth has ever seen. Scutosaurus belonged to a group of animals called Periosaurs. These were big, stocky plant-eaters with barrel chests, short tails, and thick limbs that stuck out to the sides like heavy pillars. An adult Scutosaurus could reach almost 3 meters in length and weigh as much as a small car. Its ribs formed a wide, rounded cage to hold a huge gut, needed to process coarse plants that other animals might have ignored. The protection on Scutosaurus was the most noteworthy aspect about it. The skin on its back, sides, and hips had small bony pieces inside it. These are called osteoderms. It ranged from being flat to having low bumps and spines. Together, they made a rough shield that the animal would have found hard to bite. Its brain had extra ridges and knobs that made it look twisted and almost swollen. If a hunter came by, Scutosaurus would not have looked like an easy meal. Its legs were short and powerful, held in a somewhat sprawling pose. This stance did not allow fast running, but it did let Scutosaurus plant itself firmly when it needed to. Instead of trying to sprint away, it could lower its body, brace its limbs, and turn its armoured sides toward danger. A charging carnivore faced a wall of bone, hide, and muscle, not a soft target. Even if teeth found a grip, they had to punch through plates and thick skin before reaching anything vital. The skull and teeth show that Scutosaurus was a pure plant-eater. Its jaws carried leaf-shaped teeth with tiny ridges, well suited for slicing plant material. The jaws met in a way that allowed a basic chewing motion, pressing and grinding leaves and stems, rather than just snapping them off. Combined with its massive body, this suggests a lifestyle built around constant feeding. day after day, it would have wandered between patches of low plants, pulling up whatever greenery the dry climate allowed. Fossils of Scutosaurus are especially well known from regions that are now Russia. Many bones come from river and lake deposits, where animals likely gathered during dry seasons. In a landscape that swung between wet and dry, waterholes became crowded, noisy places filled with predators, scavengers, and nervous herbivores. A heavily armoured body made a real difference there. While faster animals panicked and ran, Scutosaurus could push forward through the crowd, trusting its shell. That armour may also have served another purpose: combat with its own kind. The bony knobs on the skull and shoulders looked like places that could withstand impacts. Some scientists think Scutosaurus individuals may have shoved or rammed each other during mating season, much like modern goats or musk oxen. Two heavy bodies slamming side to side, plates grinding, dust flying around them on a dry Permian plain, would have been an impressive sight. Even though Scutosaurus had defense, it lived in a dangerous world. In the same floodplains, big saber-toothed therapsids, like Gorgonopsians and other hunters, roamed. Young Scutosaurus, that were still building up their full sets of plates, would have been in the most danger. Bone beds, with more than one animal on them, suggest that these animals may have lived in small groups, where they felt safer when they were together. A child by himself was easy to attack, but a group of armed adults, each with their back straight and their face turned outward, was something else entirely. Lycaenops, the wolf of the Permian plains. In the Permian, not all killers were big and slow. Some of them looked more like fast dogs than big alligators. One of them was Lycaenops. Its name means wolf face, which is a good description. The nose of this medium-sized hunter was narrow, and its eyes looked forward. Its long legs let it move quickly and lightly across the dry plains of what is now South Africa. Lycaenops belonged to the same broader group as Gorgonops and Inostrancevia, the Gorgonopsians. These were saber-toothed therapsids, distant relatives of mammals, that ruled the end of the Permian as top and mid-level predators. But while some Gorgonopsians grew massive and heavy, Lycaenops stayed smaller and more agile. Most species were roughly the size of a large dog. That body plan opened up a different way of hunting from the giant skull crushers of its time. The skull of Lycaenops shows a long, low profile with big openings for jaw muscles and large eye sockets. Its canine teeth were long and sharp, though not as oversized as those of the biggest Gorgonopsians. Behind them, the rest of the teeth formed shearing edges, good for cutting flesh into manageable strips. When Lycaenops bit down, it could stab and slice in one motion, opening quick wounds instead of slowly grinding. What makes it unique are its limbs. The shoulder and hip joints are shaped so that the legs can swing mostly from front to back, rather than out to the sides like the legs of many snakes. If you want to run and turn quickly, that stance is better. It looks like Lycaenops could move quickly and smoothly by leaping. This is because the bones in its wrists and lower legs are thin but strong. It probably didn't wait in wait along a riverbank, but instead walked and ran across open land. Fossil sites in the Karoo Basin where Lycaenops is found preserve entire communities. In the same layers, we see bones of medium-sized plant eaters, smaller insect-eating creatures, and big, slow herbivores. Lycaenops fit right into the middle of that web. Too small to tackle the largest animals on its own, it probably focused on young herbivores, smaller therapsids, and anything weak enough to catch. Its sharp senses and quick legs made it dangerous even without massive size. Some paleontologists have wondered if Lycaenops might have hunted in loose groups. There is no firm proof of pack hunting. Fossils rarely show behavior that clearly. But the combination of moderate size, speed, and cutting teeth invites the comparison to modern wolves and wild dogs. If several Lycaenops moved together, they could have tested herds for weakness and harassed larger prey until it broke away. On the inside of its bones, Lycaenops tells a different story. one of fast growth and full lives. Like other advanced therapsids, it didn't grow slowly and steadily like most reptiles, as shown by bone tissue. Instead, it looks like it grew quickly to adult size and then stopped growing. That shape fits an animal whose body temperature was higher and more stable, and whose lifestyle required it to move around a lot, have sharp senses, and act quickly. Its world was harsh. The late Permian climate swung between wet and dry seasons, and over longer times things were getting worse. Rivers shrank, plants changed, and big volcanic events far away slowly poisoned air and water. In such a shifting environment, being small and fast could be an advantage. Lycaenops did not need as much food as the giant predators, and it could follow prey into places larger hunters found difficult. Eryops, the amphibian that ruled the rivers. You get down on your knees by a Permian pond. The bank is dirty, the air smells like warm water and rotting things, and the water seems calm on the surface. Then something rises from the water, a big flat head with eyes on top, like a crocodile's, and a wide body that is pulling itself up to the shore. This is Eryops, which was a very large frog for its time. Eryops was a temnospondyle, part of a broad group of early amphibians. Most adults were a little over 1.5 meters long, but the largest could reach around 3 meters, making it one of the biggest land vertebrates of its time. Its name means drawn-out face, and the skull alone could be nearly 1/2 meter long, thick with bone and full of teeth. Those teeth show what it ate. The jaws carried rows of conical teeth along the edges and extra teeth on the roof of the mouth, forming a cage for slippery prey. Once Eryops snapped shut on a fish or small reptile, the victim had almost no way to wriggle free. The teeth were not built to slice neat pieces. They were there to hold on while the animal shook, twisted, and swallowed its catch whole. For a long time, artists showed Eryops as a sluggish swamp dweller floating in deep water. Newer studies of its skeleton give a different picture. The torso is short and stiff, with strong ribs and a solid backbone, and the tail is thick but not long and finned like a true swimmer's. These features suggest that Eryops was a poor swimmer compared with some relatives and preferred shallow water and margins instead of open ponds. The shoulder and hip bones are large, the legs are sturdy, and the joints are well ossified, able to carry a heavy body on land. Many researchers see Eryops as semi-terrestrial. It breathed air, walked with a slow, sprawling gait, and probably spent much of its adult life on or near land, returning to water mainly to feed and breed. Trackways from similar animals show footprints pressed into ancient mudflats, with the body held just above the ground. Its skin was not smooth like a frog's. A rare mummy specimen, where skin impressions were preserved, shows a pattern of oval bumps across the body. In life, that would have given Eryops a rough, warty texture, more like armor than slick amphibian skin. The bumps may have helped protect it from tooth marks and scrapes, and slowed water loss when it hauled itself onto sunny banks. Eryops lived in lowland systems of ponds, streams and rivers across what is now the southern United States. Many fossils come from the Texas red beds, where its bones lie mixed with fish and early reptiles. The shape and layout of the teeth suggests that Eryops focused on large prey such as lungfish, armored fish and smaller tetrapods that strayed too close to the water's edge. In those habitats, it filled a role similar to that of modern crocodiles. Its life cycle was also different from that of most modern amphibians. Early Eryops started out as aquatic larvae with external gills, but instead of a sudden metamorphosis like a frog's, they changed slowly, adding adult features over time. Bone studies point to slow, steady growth that could last many years. Juveniles probably lived in quieter swamps and side channels, where they were safer from big predators, while adults patrolled the main waterways. Recent computer models of Eryops's limb joints indicate that it may occasionally be able to pull its back limbs further under its body when it is standing up straight. That would have helped its speed and balance when going over rough ground by letting it push its body higher. When put together with its strong spine, this points to an animal that was awkward but strong on land, able to climb between pools instead of getting stuck in one place. Titanophoneus, the Titanic murderer. In Russia, in the Middle Permian period, a long time before dinosaurs existed, one of the most dangerous animals on land was called Titanophoneus, which means Titan murderer. It hunted on hot floodplains with rivers and temporary lakes. It had a long body, a thick head, and a lot of heavy teeth. Titanophoneus was a dinocephalian therapsid, part of the same broader group as Anteosaurus, but with a slimmer, more stretched out build. Adults were about 4 to 5 meters long, with a big head, a barrel chest, and a long tail. The bones show thickening around the skull and jaws, yet the backbone and limbs suggest an animal that could walk steadily and turn well, not just drag itself like a log. Its skull is one of the most impressive features. From the side, it looks tall and blocky, with heavy bone over the eyes and a deep snout. Big openings behind the eyes held strong jaw muscles. At the front, Titanophoneus had large, curved canine teeth. Behind them, shorter blade-like teeth formed a row of cutters. Together, this set was perfect for seizing flesh and ripping it away in big chunks. Inside the head, the brain case and sense organs add more detail. The brain cavity was modest in size but wrapped in thick bone. The long snout had space for smell organs, so scent was likely a major guide. Smell would help it find water, follow herds, and pick up the trace of wounded or dead animals. The rest of the body matched a life of heavy, patient hunting. The neck vertebrae were strong enough to support the deep skull and to swing it in a strike. Ribs formed a broad chest, where lungs and heart had room to support an active lifestyle. The limb bones were thick, with joints that placed the legs partly under the body instead of flat to the sides. That gave Titanophoneus a slightly raised stance and a longer step than many reptiles of its day. It probably did not sprint like a modern big cat, but it did not need to. The plains it hunted on were filled with large, slow herbivores, such as tapinocephalid dinocephalians and parasaurs. These animals had size and sometimes armour, but not much speed. A likely hunting style for Titanophoneus was to patrol near river crossings and low spots where herds gathered, then rush forward in a short, powerful charge when a weak or distracted animal came close. The fossil record hints at this mix of roles. In several bone beds, Titanophoneus remains lie among scattered herbivore bones. Some plant-eater bones carry tooth marks that match its teeth, showing that it fed on big prey. In hard times, it likely did not care whether the animal it ate died minutes or days earlier. With its thick skull and strong jaws, Titanophoneus could bully smaller predators away from a carcass and tear off tough pieces they could not bite through. Some Titanophoneus bones that were hurt and then healed show that life was hard. Breaks in the bone that have grown back and rough spots show hits and stress that did not kill the animal. These can happen when Titanophoneus protect animals, when they fall on uneven ground, or when they fight with other Titanophoneus over mates or kills. Something that big had to be strong enough to not only fight, but also keep going after hard hits. The environment Titanophoneus lived in was not stable. River channels shifted, dry seasons could be harsh, and plant life changed as climates warmed and dried. To survive, it had to be flexible, follow migrating herds, hunt in different places as water moved, and swap between hunting and scavenging, depending on what the land offered. Its long body, strong sense of smell, and crushing bite made it a powerful generalist at the top of the food chain. Moschops, the head-butting herbivore. Two short forms stand next to a muddy river on a hot Middle Permian day in what is now South Africa. Their bodies are barrel-shaped, their necks are short and thick, and their heads look like striking rams. They stamp, slam their heads together, and make a noise that can be heard over the hills. These are Moschops, animals that eat plants and have turned their heads into weapons. Moschops was a dinocephalian therapside, a large synapside on our own side of the family tree. Adults were around 2.5 to almost 3 meters long, with a low, heavy body and a relatively small head. Their fossils in the Tapinocephalus assemblage zone of the Karoo Basin show that they lived about 260 million years ago, long before any dinosaur took a step. Its body was built for bulk. The ribs form a wide, rounded cage that would have held a huge gut, needed to process tough, low-quality plants like cycad stems and woody shoots. The legs were sturdy and set partly under the body, not sprawled completely to the sides, and studies of the elbow joints show they could open more widely than in many other early plant eaters. That gave Moschops a somewhat more upright, mammal-like stride, even if it was never a fast runner. The skull is where Moschops truly stands out. The bone across the roof of the head is greatly thickened. In cross-section, that roof is a solid block instead of a thin shell. The back of the skull is deep and reinforced, and the snout is short and strong. For years, this thickness led to a simple idea. Maybe they used their heads to ram each other, the way goats and muskoxen do today. High-energy scans have now backed that up. Inside the skull, the brain sat low and small inside a cage of dense bone, well protected from impacts. The canals of the inner ear, which help an animal keep balance, are shaped in a way that fits a posture with the head held forward and steady, with fast control of up and down movement. Moschops seem to have been wired from skull roof to inner ear for controlled collisions. Why would a plant eater need that? The most likely answer is combat with its own kind. In a crowded floodplain where water and good plants could be limited, it mattered who owned the best feeding spots and who won in mating season. Two adults lowering their thick skulls and slamming together could settle rank in seconds. The loser moved on. The winner kept the prime ground and the best chances to pass on its genes. Its teeth and jaws match a life spent grazing. Moschops had stout, long-crowned teeth that could grip and crush rough plant matter. Dental studies on tapinocephalid relatives show strange enamel patterns and worn chewing surfaces similar in some ways to later plant specialists like certain dinosaurs and hoofed mammals, but with simple features like constant tooth replacement still in place. A new twist is added by bone histology. Some experts think that the fact that the leg bones have a thick outer wall and a soft inner structure means that the animals lived in water some of the time. This animal might have spent a lot of time in or near shallow water, rolling like a hippo's to stay cool and ease the strain on its joints. It would then move to solid ground to eat plants growing along the shore. Estemmenosuchus, the horned oddity of evolution. This animal looks like what you would get if you took a hippo, cut its legs shorter, spread its body out, and then stuck horns and bumps all over its head. Scientists of the time didn't even know what to compare this Middle Permian animal from what is now Russia to. It looked so strange. It had a wide, heavy head with side horns that looked like antlers. Its nose and cheeks had knobs, and its body looked like it was made for slow power rather than speed. Estemmenosuchus was a dinocephalian therapside, part of the same larger group as Moschops and Anteosaurus. Adults could reach more than 2.5 meters in length. The legs were short but strong, holding up a deep chest and a big, rounded belly. Its tail was not long and whip-like, but thick and fairly short. Taken together, the skeleton suggests an animal that stayed close to the ground, with a low center of gravity, moving in a steady, plodding walk. It was not chasing anything for long distances. The skull is the real show. Estemmenosuchus means crowned crocodile, and the crown is a maze of bony growths. Large horns project sideways from the top of the skull, like short branches. Extra bosses rise from the snout and above the eyes. In some individuals, a second set of side horns seems to grow lower on the head, giving the animal a stacked, multi-level look. These structures were not thin, fragile spikes. They are built from thick bone and tie into strong parts of the skull, meaning they could take hits without snapping off. What were the horns for? One simple idea is defense, but their position makes them more useful in head-to-head clashes than against predators. Many researchers think Estemmenosuchus used them to push and shove members of its own species. Two animals could face each other, lock horns and facial bumps, and drive forward, testing strength. The thick skull roof, strong neck, and heavy body all support this picture of low, grinding contests. Winning those fights may have decided who held the best territory, or who got more chances to mate. The teeth and jaws tell a slightly different story from some other dinocephalians. Estemmenosuchus had broad, leaf-shaped teeth that are good for cutting plant material, but the front of the mouth also carried forward-pointing teeth that could grip. Some scientists see this as a sign that it was not a strict plant eater. It might have been an opportunistic omnivore, browsing on low plants most of the time, but also snapping up small animals, eggs, or carrion when it could. In a warm, seasonal world with dry spells, such flexibility would be useful. Studies of its bones suggest it may have spent much of its time near water. The structure of the ribs and limb bones fits an animal that could support its weight on land, but did not move quickly. The big torso would have floated well in shallow pools, taking pressure off the legs. Some paleontologists picture Estemmenosuchus wallowing in muddy channels to cool off, then climbing onto banks to feed on ferns, seed ferns, and young shrubs. With its odd head held low, it might have looked like a living boulder browsing through waist-high plants. It lived with other Permian animals, such as early frogs in the rivers, sail-backed synapsids, and smaller therapsids on land, and thick-bodied herbivores that wore their own armour or hats. Estemmenosuchus fit in this group because it was a medium to big browser that was naturally safe and ready to fight other species of its own kind. For hunters, it was a dangerous target. When you hit it in the neck or shoulders, those hard, pointed spikes would hurt you. The body was big, and the head was heavy. Diplocaulus, the boomerang-headed swimmer. One animal lived in streams and ponds in the late Carboniferous and early Permian. It looked like a living mark that was drawn across the water. It had a short body, a thin tail, and two long bent horns on each side of its head. From above, it looked like a huge boomerang slowly moving under the water. Diplocaulus was one of the strangest frogs ever found. Diplocaulus was a lipospondal amphibian, usually less than a metre long from nose to tail tip. Its most striking feature, the boomerang-shaped head, came from huge bones jutting sideways from the back of the skull. These horns were not thin spikes, they were broad, flat blades of bone, strong enough to support skin, muscles, and blood vessels. In life, they may have carried a layer of cartilage and soft tissue that made the head even wider than the bones alone suggest. For a long time, no one was quite sure what that head was for. Some early ideas suggested defense, with the wide skull stopping predators from swallowing Diplocaulus whole. A fish or larger amphibian might grab the middle of the body, only to find its jaws blocked by the horns at the back of the head. That is still possible, but newer work points to a more active role: hydrodynamics. The shape of the head seems to have turned water flow itself into a tool. In computer models, scientists have tested how water moves around a Diplocaulus-shaped head compared with simpler skulls. The results show that the boomerang form could create lift, like a wing turned sideways in water. As the animal swam forward, water pressure would be lower above the head and higher below it, gently pushing the animal upward. That meant Diplocaulus could hover and rise in the water column with less effort, from its limbs and tail. Instead of constantly paddling, it could glide. This makes sense when you look at the rest of the body. Diplocaulus did not have a long, powerful tail fin like some other ancient amphibians. Its tail was narrow and its limbs were modest. It looks less like a fast pursuit swimmer and more like a slow, careful glider. With a lifting head, it could move near the bottom, then tilt slightly and let its skull pull it up toward the surface, ready to snatch insects, small fish, or other tiny animals that came within reach. The eyes of Diplocaulus sat high on the skull, facing partly upward. That placement is perfect for watching what happens above, while the rest of the body stays low and hidden. From a predator's point of view, only the curve of the head and the glint of the eyes might break the surface. From the prey's point of view, danger would seem to come from nowhere as the wide skull rose from below. Fossils of Diplocaulus are especially common in the famous Permian red beds of Texas and nearby states. Many skeletons preserve the full outline of the head, giving us clear proof that this shape was not a one-off oddity, but a stable design used over many generations. Some related species had even more extreme horn shapes, while others had shorter, stubbier heads, suggesting that different lineages tested slightly different solutions to the same problem of moving and feeding in shallow water. As you can see from the bone tissue inside the horns, they were made up of a mix of thick bone and lighter, more flexible bone. This gave them the right balance of strength and weight. It would have been hard for the animal to keep its head from sinking if the horns were too solid and heavy. Diplocaulus could hold up the wide skull with this mix without making it into a stone anchor. Diplocaulus would have looked weird on land. It had small limbs and a big head that would have made it hard to walk. Most likely, it only crawled a short way between pools or to rest on mud banks. But when it got wet, that weird head turned into a glide plane. Early frogs, fish, and more snakes made the world a busy place. Diplocaulus stood out by doing something that almost no one else did. It rode the water on the shape of its head. Cynognathus, the mammal reptile that never stopped running. Picture a creature that looks like a mix of a dog and a snake. There was a fast-moving hunter called Cynognathus in the early Triassic, just a few million years after the Permian extinction that almost wiped out all life on Earth. Cynognathus was already running quickly across floodplains, trying out ideas that real mammals would later perfect. At the time, many animals were still small and slow. Cynognathus was a large cynodont, one of the closest relatives to true mammals. Adults reach roughly 1 to 1.5 meters in length. The skull was broad at the back for strong jaw muscles and narrowed into a short, powerful snout. Inside the mouth, the teeth did not all look alike. There were sharp incisors at the front, long canines behind them, and farther back, teeth with raised cusps that could mesh together. This mixed set is an early version of mammal-style cheek teeth, able to grip, slice, and crush food, instead of just snapping it. Those teeth and jaws show that Cynognathus was a meat-eater, but not a simple bite-and-swallow hunter. It could cut and chew its prey enough to break down muscle and tougher tissue before gulping it down. That meant it could pull more energy from each meal, feeding a more active body. In a world of harsh seasons and uneven food supplies, being able to use food more efficiently was a major edge. The body matched this higher energy life. Unlike many reptiles, Cynognathus carried its legs mostly under the body, not sprawled out to the sides. That upright posture is better for running because the limbs swing forward and back like pendulums instead of pushing sideways with each step. The limb bones show strong joints and proportions suited to long strides and quick turns. The backbone seems flexible enough for a slight up and down bend when running, which would lengthen the stride in a sprint. Much like we see in many mammals today, its chest and ribs hint at powerful breathing. A deep ribcage would have held strong muscles to pull air in and out in a steady rhythm, supporting longer bursts of activity. Some researchers think cynodonts like Cynognathus may already have had a simple diaphragm-like muscle helping them breathe more efficiently. Combined with its teeth, limbs and likely higher body temperature, this makes Cynognathus feel much closer to a mammal than to a lizard in how it lived, even if it still laid eggs. Fossils of Cynognathus are known from South Africa, South America and Antarctica, all parts of the old southern supercontinent Gondwana. Its presence on 3 continents tells us it was both successful and widely spread. It could handle different environments, from river valleys to uplands, and it also confirms that these lands were once joined, because the same animal could roam across regions that now sit oceans apart. In some rock layers, its bones are so common that entire geological zones are named after it. We can't see its skin in the remains, but similar cynodonts give us hints that it might have had fur or hairs on its body. There are bone traits in a lot of close cousins that are linked to having high, stable body temperatures. Later members of the group were almost certainly furry. Cynognathus was probably a thin hunter about the size of a dog. It had a long tail, eyes that were always on the hunt, and hair that kept it warm on cool Triassic nights. Tapania and Acanthosaurus, the microbial architects of ancient ecosystems. Life on Earth was very important before it had teeth, claws, or even bodies. It was almost impossible to see. Sunlight and chemicals were turned into energy by tiny cells that floated, clumped, and spread out across shallow seas. Microbes like Tapania and Acanthosaurus were among these early forms. These names refer to very different types of microbes that helped shape whole worlds long before Dimetrodon or Gorgonops showed up. Tapania is known from rocks more than 1 billion years old. Under the microscope, it looks like a small bubble with threads and bumps sticking out of it, like a spiky balloon. Those shapes tell us it was not just a simple bag of jelly. Many scientists think Tapania was one of the first complex cells, with an organized interior and a flexible outer surface. It may have been fungus-like, algal, or something that does not fit any modern group neatly, but it was already using tricks we now see in advanced microbes: branching, attaching to surfaces, and building networks. In the ancient seas, Tapania did not live alone. It was part of thick microbial mats that coated the seafloor in quiet bays and lagoons. Picture sticky carpets made of countless cells layered on top of each other. The top layer soaked up sunlight and released oxygen. Layers below used waste from the layers above. Over time, minerals in the water stuck to these mats and hardened, forming lumpy structures like stromatolites and other microbial reefs. These slow-growing buildups change coastlines and raise tiny underwater hills where currents and nutrients move differently. What made these mats so important was their effect on the atmosphere. For millions of years, early microbes pumped out oxygen as a byproduct of photosynthesis. At first, that oxygen reacted with rocks and dissolved metals in the water. Only after those sinks filled up did free oxygen begin to build in the air and oceans. By the time animals evolved, the work had already been done by countless generations of cells, like the ones represented by Tapania. Without them, there would not have been enough breathable oxygen for big, active creatures to survive. Acanthosaurus is the next part of this story about tiny builders. The genus Tapania lived a long time before animals did. Acanthosaurus, on the other hand, is the name of later microscopic plankton that had hard shells that fell to the bottom when they passed. There were forms that made shells out of silica and forms that made shells out of carbon rocks. In either case, they turned thin, floating life into solid stuff that helped make layers of thick soil. As the years went by, these layers turned into chalks, cherts, and other rocks that keep carbon and nutrients inside. Floating near the surface, Acanthoceras and its kin formed the base of entire food webs. Small swimming animals fed on them. Larger animals fed on those swimmers. Even the biggest marine reptiles and fishes of later eras ultimately depended on plankton blooms that started with tiny cells turning light into food. When conditions were right, huge blooms could tint the water a different colour, change how much light reached deeper layers, and alter temperatures near the surface, all from the collective action of bodies too small to see with the naked eye. The shells of Acanthoceras also acted like countless parachutes for carbon. Every time a cell died and its shell sank, a bit of carbon moved from the surface waters to the deep. This slow rain of particles, called marine snow, in modern oceans helps keep climate in balance by sending carbon into long-term storage in the seafloor. As these sediments are buried and turned into rock, they hold that carbon for ages, until plate movements and uplift bring them back up, or volcanoes release some of it through melting. Cotylorhynchus, the balloon-bodied giant. If the Permian riverbed had been dry, you would have seen Cotylorhynchus a long time before it got close. A small head bobbed in front of a big, round body that was supported by short legs that looked like beams. This strange synapside lived in what are now Texas and Oklahoma about 275 million years ago. It was one of the biggest land animals of its time and looked a lot like a cartoon character. Cotylorhynchus belonged to the casids, early relatives of mammals. Its body plan was extreme, even for that group. The skull was small and light, with a short snout and very large nostril openings, while the torso was enormous. Long, heavy ribs curved outward to form a deep barrel, leaving room for a vast gut. That huge body was not for show. It was built to process huge amounts of tough, low-quality plants in a harsh, seasonal climate. The teeth and jaws confirm this lifestyle. At the front of the mouth, longer, narrow teeth helped grab stems and branches. Farther back, spatula-shaped teeth with 3 tiny points on each crown sliced and mashed plant material. Instead of stabbing or cutting meat, Cotylorhynchus cropped, shredded and swallowed vegetation that many other animals could not handle. Inside its belly, slow fermentation by microbes would have broken down the plants and released energy. Its limbs were short but very sturdy. The shoulder and hip joints suggest a mostly sprawling posture, but the legs were strong enough to hold a heavy body off the ground. The hands and feet were broad, with short, strong toes ending in curved claws. Those claws may have helped it dig at roots, pull down branches, or push through soft mud after monsoon rains. It probably moved at a steady walk, rather than in bursts of speed. Bone studies revealed something surprising about this giant. The limb and rib bones have very thin outer walls and a spongy interior. One research team argued that this light, osteoporotic structure pointed to a semi-aquatic lifestyle, with Cotylorhynchus spending much of its time in water and only coming onto land briefly. They also suggested that its chest joints allowed little rib movement, so it might have used a simple diaphragm-like muscle to breathe, an early step toward the mammal-style diaphragm. Other researchers strongly disagreed. They pointed out that Cotylorhynchus skeletons are found in rocks laid down by rivers and floodplains that were dry between seasonal storms, mixed with land animals adapted to heat, not with clearly aquatic fish or amphibians. The feet look built to support weight on soft ground, not to act as paddles, and the tail shows no sign of a swimming fin. To them, Cotylorhynchus was mainly a land browser that may have waded or wallowed, but did not live like a seal or a manatee. There is still some disagreement, but most people agree on a medium ground. This idea says that Cotylorhynchus spent most of its time on land, slowly moving between patches of hardy plants. It also said that it used shallow water as a safe place to hide. It would be able to support its weight, keep its body cool, and maybe even breathe easier if its stomach did most of the work. When it stopped raining and the ponds dried out, the chances of getting too hot, getting hurt, or going hungry went up very fast. The fact that many species of Cotylorhynchus had broken and healed ribs shows that it was able to escape heavy impacts. This could happen if it falls on uneven ground, gets knocked over in a crowded area during a flood, or is attacked by a big animal trying out its defenses. It doesn't matter what caused the bone to heal, it shows that this animal's slow body was tough. It could get hurt, keep eating, and live long enough for its bones to tell the story. Diictodon, the burrowing pair that lived together. Moving dirt was under the dry Permian lands that are now South Africa and China. It wasn't moving on the surface. Tunnels that went in all different directions ran under your feet. Some ended in small rooms, while others split off like tree roots. The Diictodon lived in many of these holes. It was a common small animal at the time. Diictodon was only about 1/2 meter long, had a round body and tusks like a small pig. It wasn't a fierce hunter or a big grazer. It instead stayed alive by digging deep, living in pairs, and building a fortress in the ground. Diictodon was a dicynodont, a group of early synapsids more closely related to mammals than reptiles. Unlike the huge herbivores and predators around it, Diictodon kept things simple. The skull was short and sturdy, with a beak-like mouth perfect for clipping plants. Most individuals had a pair of small tusks jutting from the upper jaw. They weren't for fighting large animals, but served as multi-purpose tools, scraping roots, digging in loose soil, and maybe signaling to other members of the species. The most astounding thing about it was that it could dig. The front limbs were short but strong, with wide hands and sharp claws. The shoulder girdle's bones were strengthened so that they could handle the repeated pushing and pulling that was needed to dig caves. Because the ribs made the body small, it could fit through small spaces without rubbing against the walls too much. Diictodon was built in a way that made it look like it lived underground. When paleontologists first uncovered Diictodon fossils, they noticed something surprising. The animals were often preserved inside the burrows they had dug. Even more surprising, many burrows contained 2 individuals lying together. These pairs were often similar in size, suggesting they might have been mates, siblings, or close social partners. This is one of the earliest hints of stable social behavior in a mammal-line creature, a lifestyle where 2 individuals shared a home, protected each other, and perhaps raised young together. The burrows themselves reveal more about their world. Many were dug into firm, fine-grained soil, then coated naturally with minerals over millennia, preserving their shapes. Some tunnels curved gently downward before widening into a resting chamber where the animals could sleep, hide from predators, or escape the scorching heat of the dry season. Others split into multiple side chambers, showing that Diictodon did not always live alone. Entire networks might have been used by groups or by generations of the same family. Life above ground was dangerous. Large Gorgonopsians prowled the plains. Giant herbivores stirred up dust storms as they moved. Seasonal droughts hardened the soil and killed off surface plants. By burrowing, Diictodon avoided most of these dangers. Underground temperatures stayed stable. Humidity remained higher, keeping the animals from drying out. Even wildfires sweeping across the Permian grasslands would have passed over burrow systems without harming the occupants. What Diictodon ate also helped it stay alive. Its beak and simple grinding surfaces were perfect for eating tough twigs, roots, and dry plants that had died off during certain times of the year. Because it could dig, it could find food that was hidden that other plant eaters couldn't. During droughts, Diictodon probably ate deep storage roots to stay alive, while other animals died of hunger. Because it was small and had a fast metabolism, it needed less food than most of the animals around it. Evidence from bone growth shows a steady life rhythm. Diictodon didn't grow explosively fast like later mammal ancestors, but it didn't grow as slowly as reptiles either. Its bones show patterns of active growth interrupted by short pauses, likely reflecting seasonal changes in food and water. Young individuals probably stayed in the burrow for protection until they reached a size safe enough to wander short distances above ground. Predators sometimes broke into holes, and fossils of some skulls show that they had wounds that had closed, which suggests that the animals got away quickly. But near the end of the Permian, when temperature changes got really bad, that was the biggest danger. As droughts got worse and plant groups died, it got harder for even experienced survivors like Diictodon. A lot of burrow fossils show dramatic scenes, like two animals that were caught together by rapid floods or poisonous gases that seeped into tunnels. This frozen moment paints a scary picture of a species designed to survive in a world that was quickly falling apart. Lystrosaurus, the survivor that outlived the apocalypse. Going back in time to the early Triassic, right after the Permian mass extinction, the land would look mostly empty. There were no more forests. Rivers were full of dead plants. The air was rough and dirty. Over 90% of the animals were no longer there. One thing, though, kept going through this broken world with no giving up. The animal was called Lystrosaurus, and it was about the size of a pig. It had a beak, tusks, and a body made for endurance. Lystrosaurus didn't look special at first glance. It had a short snout ending in a hard beak, a pair of forward-pointing tusks, a barrel-shaped body, and thick legs that angled out like sturdy pillars. But that simple design ended up being the perfect survival toolkit for a world in collapse. When everything else fell apart, Lystrosaurus just kept going. To understand why it survived when so many others didn't, you have to look at its entire lifestyle. First, its feeding habits were built for bad times. Lystrosaurus used its beak to snip tough stems and scrape underground roots. Unlike picky eaters that needed soft leaves or fresh growth, Lystrosaurus could dig for buried plant remains even during long droughts. Its jaw joint was strong, and its wide cheeks hint at heavy muscles for chewing rough material. Inside its barrel-like body sat a long gut that could pull energy from plants almost no one else could use. Its body also hints at another advantage: burrowing. The forelimbs were powerful, with strong upper arm bones and wide hands perfect for shoveling dirt. Many paleontologists think Lystrosaurus regularly dug shallow burrows for shelter, either to escape heat, hide from predators, or ride out dangerous weather. Burrowing would have protected it from temperature swings, wildfires, and choking ash settling from distant volcanic eruptions, events that wiped out countless other species. In a world full of environmental attacks, having a home underground was priceless. Its breathing system was also very important to its life. Many older synapsids breathe by moving their ribs, but Lystrosaurus may have started using muscles that work like the diaphragm to pull air into the lungs more effectively. The bones inside the rib cage aren't very flexible, which suggests that the ribs weren't doing all the work. This more advanced way of breathing might have helped Lystrosaurus stay active, even when there wasn't much oxygen in the air, which was a problem right after the dinosaurs died out. Lystrosaurus took big breaths and kept going while other animals gasped. Growth patterns in its bones also reveal a strange secret. When scientists slice through Lystrosaurus bones, they find lines that suggest rapid early growth, followed by sudden pauses. These pauses most likely reflect harsh seasons or environmental disasters. The animal could switch between grow fast and pause everything modes depending on conditions. That kind of flexibility is rare and incredibly useful during extinction-level chaos. Lystrosaurus wasn't the most powerful animal in its world, but it didn't have to be. Like pigs and antelopes today, it probably lived in bands or loose groups. When they moved in groups, they were safer from predators and had a better chance of finding food. Few big animals were left in the early Triassic, but young Lystrosaurus still ran the risk of being eaten by archosaur predators that were still alive. Their chances would have been much better if they had lived in a herd. The real surprise, though, is how successful Lystrosaurus was after it died out. Over 70% of all the bones from land vertebrates in some ancient layers belong to this one species. Whole environments were like Lystrosaurus with a side of everything else. As it spread across large parts of Pangaea, like South Africa, India, and Antarctica, it showed that it could survive heat, cold, drought, and regular storms. At that time, no other animal had the same area or number of individuals. As climate stabilized and new groups like early dinosaurs and mammal relatives expanded, Lystrosaurus slowly faded. It didn't go out in a dramatic final battle. It simply stepped aside as new species filled the recovering world. But its legacy is huge. It proved that in times of extreme collapse, survival doesn't always belong to the strongest or fastest. Sometimes it belongs to the adaptable, the efficient, and the stubborn. Inostrancevia, the apex killer of the Russian wastelands. One hunter ruled the harsh landscapes of what is now northern Russia in the last few million years of the Permian period, a long time before dinosaurs developed. It was a giant Gorgonopsian named Inostrancevia. It had long saber-toothed teeth, a deep brain and strong jaws, making it the last great apex hunter before the world ended. Inostrancevia lived during the late Permian, when the climate was unpredictable and the land was dry, windy, and scattered with tough vegetation. Many animals were already struggling as environments shifted, but Inostrancevia thrived. Adults stretched nearly 3.5 meters long, making them the largest known Gorgonopsians. Their long bodies, tall shoulders, and sturdy limbs gave them a surprisingly high stance, compared with other predators of the time. They were not belly-dragging reptiles, they were active, mobile hunters. The skull of Inostrancevia is its most famous feature. It was long and narrow, with huge openings for jaw muscles, allowing a crushing bite, but its defining weapons were the saber teeth, two upper canines that could reach more than 10 centimeters in length. Unlike the later saber-toothed cats that used broad, curved teeth, Inostrancvia's sabers were sharper, thinner, and designed for precision. They weren't made for slicing through armor like a knife. They were made for stabbing deep into soft tissue, ending the fight quickly. Scientists believe Inostrancevia didn't use those sabers recklessly. A misjudged strike could break them. Instead, it likely targeted weak spots, throats, bellies, and the softer areas behind limbs. Its jaw muscles helped hold prey steady, while the saber teeth delivered the killing puncture. Each attack had to be fast and accurate, a perfect blend of speed and violence. The rest of the skull adds even more detail. Behind the eyes, large temporal openings anchored huge jaw-closing muscles. The snout was stiff and strong, keeping the skull from bending during attacks. Its eyes faced slightly forward, giving it better depth perception than many earlier predators. That improved its ability to time lunges and track prey during chases. Inostrancevia spent its life chasing animals that were just as unusual. Its world was filled with strange herbivores, Scutosaurus with armored backs, Moschops with massive, reinforced skulls, and various tusked Diictodons digging for roots. Hunting these animals was dangerous. Inostrancevia needed both power and strategy. It probably stalked prey from a distance, rushed forward in a burst of speed, and aimed for a disabling bite before the victim could defend itself. Tracks and skeletal studies suggest Gorgonopsians had a semi-upright posture, with limbs tucked slightly under the body rather than splayed like a lizard's. That would have made Inostrancevia faster and more agile than other carnivores of its time. Its long tail helped it balance during quick turns or leaps. Although it wasn't built for long-distance running, it excelled at short, explosive attacks. Signs that Inostrancevia grew quickly can be found in its bones. This is more typical of animals than snakes. Being able to grow quickly would have helped it get big fast, leaving less time for bigger animals to attack. Its bone tissue also shows that its metabolism was active, which is another sign that these scary hunts were not just cold, slow-moving reptiles. They were warm, awake, and full of energy all the time. But even an apex predator cannot escape a dying world. As the Permian spiraled toward its final extinction event, drought, volcanic gases, and collapsing food webs struck every continent. Herbivores dwindled, plants died off, and predators lost their hunting grounds. Inostrancevia was among the last of the great Gorgonopsians, vanishing just before the mass extinction hit its peak. Paleontologists made one of the most remarkable finds when they found skeletons of Inostrancevia that were found far from where they should have been found. It looks like these carnivores moved thousands of kilometers south into areas that were once controlled by other canines. It was simple. They needed to stay alive. Other top predators had already died out because of the chaos in the environment, which made a space that Inostrancevia filled temporarily. But it wasn't enough, not even this last increase. As the world kept falling apart, Inostrancevia died out along with the other species. From saber-toothed hunters to burrowing survivors that outlasted the worst extinction in Earth's history, these forgotten creatures proved the prehistoric world was already wild long before dinosaurs ever showed up. If you love exploring these ancient beasts, hit like, subscribe, and keep watching, because the past still has countless secrets waiting to be uncovered, and the next video on your screen dives even deeper into the untold side of prehistory.